Hi guys, welcome back to Dr. Abha Chemistry Pathshala. Let us continue our journey of carbonyl compounds, and this particular video is for the chemical properties of carbonyl. Important chemical properties of carbonyl are nucleophilic addition reaction, oxidation, reduction, and there are most wanted the reaction which are due to the presence or absence of alpha hydrogens. So we cannot cover all the topics in the video. So what I'm going to take, I'm only going to focus on the first leg of the flow chart, that is the nucleophilic addition reaction. Both types, the normal reactions and the ones which are followed by elimination of water, that is they give rise to the double bond, in an addition double bond. Okay, let us know more about it. Quickly jump to the screen. So let us get started with the nucleophilic addition reaction of carbonyls. So as you can see, we have divided the nucleophilic addition reaction into two categories. The first category is ordinary nucleophilic addition. In the second category, the addition is followed by some kind of elimination. In nucleophilic addition, we will add HCN, sodium bisulfite, Grignard, and alcohol across aldehydes and ketones. In nucleophilic addition reaction followed by elimination, we will add ammonia, amines, which are a special case of ammonia, hydroxylamine, again nitrogen is common, hydrazine, NH2, again nitrogen is common, phenylhydrazine, the hydrazine in which one H is replaced by C6H5, and 2,4-dinitrophenylhydrazine in semicarbazide. All these compounds, they are known as ammonia-based compounds. Let us do the key points of nucleophilic addition reaction. First, let us talk about mechanism in short. We take aldehyde or ketones reacted with HCN. This HCN has nucleophilic part and it has electrophilic part. Now, the first step, which is the slow step, which is the rate determining step. This oxygen attracts the pi electron, carbon gets positive charge, oxygen gets negative charge, and in HCN, CN is the nucleophilic part and H is the electrophilic part. So the first step is the attack of nucleophile on C, and what we get is CN here and O in form of alkoxide, which is sp3 hybridized and which will be tetrahedral. Whereas if you look at the carbonyl, it is sp2 hybridized and it is planar. Now in the second step, this alkoxide reacts with electrophile to give cyanohydrin. The product is cyanohydrins. So aldehyde will show nucleophilic addition faster than ketones. Reason being, I have taken a simple ketone and I have taken a simple aldehyde. Now, if you see, this CH3 gives plus I effect and this CH3 also gives plus I effect. Whereas here we have plus I effect only from one direction. So the electrophilicity of carbon, in the first case, it is reduced. As a result, the attack of the nucleophile is slow. Also, steric factors. Right? Because there are two alkyl groups, so sterically it will be hindered. These reactions are catalyzed by acid. Why? If you look at a ketone, you take some acid. So what will happen? You will have reaction giving formation of oxonium. Now with the presence of plus on oxygen, the carbon will attack nucleophile. So reaction is always facilitated by acid. Order of the reaction will be the fastest with aliphatic aldehyde followed by aliphatic ketone, aromatic aldehyde followed by aromatic ketone. Let's do an example of this. Suppose you want to compare reaction of this benzaldehyde with acetaldehyde. Now here what happens is, benzene will show a plus R effect and there is going to be electron density, increased in electron density on O, right? So as a result, since there is electron coming from the benzene ring, as a result, the electrophilicity of carbon will be reduced. So it is the plus R of benzene on CHO that will reduce the nucleophilicity reaction, right? Guys, please mind it, CHO is a minus R group, but when you're talking about the effect of benzene and CHO on CHO, it will show plus R because benzene is giving electron to the CHO. So this is not happening here, right? This is because now here it is showing it is CH is electron donating, but that is due to plus psi effect, but here it is happening due to resonance effect, right? So always aromatic aldehydes will show, aromatic aldehyde and ketones will show reaction slower. Guys, the way you did the reaction of aldehyde and ketone with HCN to give cyanohydrins, you will see that the reaction is reversible in nature and the product forms are known as cyanohydrins. And cyanohydrins are very important. Because CN can give rise to different functional groups. CN can give you COH, CN can give you amide, CN can give you amines with more carbon, which we can do in some other videos, right? So you can look for these information in other videos. So let us first focus about nucleophilic addition. Now here something very important is usually reaction take place in acidic medium, but this reaction will take place in, it will require some base. Why? Because HCN is covalent. It is purely covalent. So OH helps in the removal of H and nucleophile is easily generated. The other way of doing it is we can take NaCl and we can treat it with mineral acid. You can take this also, and what we get is HCN plus NaCl. So either way we can do the reaction. So please remember that this reaction needs some amount of base, unlike usual reactions which are fast in acidic medium. So let's move on to the second reaction with NaHSO3. Right? So again, we take aldehyde or ketone, treat it with sodium bisulfite. If you remember, the electrophilic part will go on oxygen and the nucleophilic part will attack on carbon. Now, here we have proton transfer. Why proton transfer takes place? Because of the formation, because the reaction proceeds in the formation of a precipitate and it gives you OH, proton shifts to oxygen, and here you get sodium bisulfite adduct. This is it is white crystalline PPT. The importance of reaction is, first, it is used to identify or as a test for carbonyl because we are getting a white precipitate. It is owned by aldehydes and ketones, aliphatic and sterically unhindered. If the alkyl groups are very big, the reaction will not come positive. So smaller alkyl groups will show it positive. Benzaldehyde will show the reaction, but aromatic ketones will not show the reaction. Acetophenone, benzophenone, they will not show the reaction. Please remember it. Next important is, this reaction is used for purification. Suppose you take the product, the sodium sulfide adduct, which you get as a white PPT, you take it and you add it in mineral acid, or you can add it in any alkali. What you do is, at the end of the reaction, you get pure aldehyde or ketone with byproducts like NaCl, H2O and SO2. You react it with base, the same reaction, you get your pure ketone or aldehyde back. Third is Grignard reagent. Addition with Grignard. We've already done this in the chapter of alcohol. When we take aldehyde and ketone and we treat it with Grignard reagent, in Grignard we know that X gets a partial negative, Mg gets a partial positive charge. So the addition will be get the positive part Mgx, C will get the negative part R. This is the addition what we get, the addition product. This addition product, it gets added to water. In acidic medium, it gets added to water, and finally what we get is, here you get OH and H, water gets added. So here we have OH and here we have R. So what we get is alcohol. You want to go through the detailed video of this. So the best way would be to go through the formation of alcohols 1 degree, 2 degree and 3 degree. So there this reaction has been very nicely explained. So let's do the key features of reaction. We can use we can use R also, we can use AR also, and whatever is the alkyl group of Grignard, alkyl or aryl group of RMGX it is transferred to carbon of carbonyl, addition of alcohols. In addition of alcohols, we take aldehydes, we treat it with alcohols. We have this electrophilic part and the nucleophilic part, and the reaction exactly takes place the way it did before. With O we have H, and with carbon we have OR, which is the nucleophilic part, and this is known as hemiacetal. Hemiacetals they have got alkoxy and alcohols, right? Now, if we take a hemiacetal and we further reacted with alcohol, right? So what it will give? It will give us acetal, that is, it will give us dialkoxy. How? So you will have, again, this is the electrophilic part, nucleophilic part, and this water comes out, right? So you will have dialkoxy, and this is known as acetal. Action takes place in presence of dry HCl. So on arrow you will have to put dry HCl. So dry HCl is to protonate the oxygen of carbonyl, and dry HCl absorbs water, leading to forward reaction. If we want to perform the reaction with ketones, we need dihydric alcohol, that is, we should have 2 OH groups. So if I take a ketone and I take ethylene glycol, it takes place in such a way that they are removed, and what we get is, these are known as ketones. It will be reversible and it will take place in presence of dry HCl. So here we get, either we get acetals or we get ketones. We have one more category where the nucleophilic addition reaction is followed by elimination. So let us quickly know the mechanism. Here we take ammonia based compounds. Suppose I take ammonia and I write ammonia like this, and this is my aldehyde or ketone. So again the reaction will follow nucleophilic addition. This is the electrophilic part, nucleophilic part, partial negative and partial positive charge. So what actually happens is, you have at O you have H, and at C you have the nucleophilic part NH2. Now this is the tetrahedral adduct. Now here what happens is, in presence of acidic medium, it removes water. How it removes water is, if you see, this OH reacts with one of the H to give H2O, and finally what we are left with? We are left with C double bond NH. This is nothing but imines. Now the key feature of the reaction is that the reaction is pH controlled. This reaction is pH controlled, because if we take acidic medium, highly acidic, which we know is good for nucleophilic addition, it reacts with base, that is ammonia or ammonia derivative, to form salt. So we will avoid highly acidic and we'll go for mild acid. Mild acidic as in 3.5 pH, something close to that. The other thing what you can notice is, this is a very simple way of learning these reactions. NH2, which is present within the ammonia based compound, and the carbonyl oxygen, they just get combined to give us simply C double bond NH. If you want, you can write this reaction in one step. This is the carbonyl compound and this is the ammonia based compound. So instead of writing NH3, I'll write it in a different way. I will write it as NH2 and H. The hydrogen which is next to nitrogen, that hydrogen with oxygen will give water. So finally what we get is The product are known as imines. Let us do the second one. We take aldehyde or ketone, we react it with primary amine. So this is again RNH2. We will write it as NH2. And what we do is just take out water. Once we take out water, what we get is C double bond N R. These are substituted amines. Next one. We take hydroxylamine. So this is amine part and this is the hydroxy part. Exactly the same way. Water comes out. We get the product are known as oximes. Reactant is hydroxyl amine. Aldehyde ketone, hydrazine is nothing but NH2, NH2. This is hydrazine. So very obvious reaction. Next two are very similar. Phenylhydrazine. So we take hydrazine and one of the hydrogen of hydrazine is replaced by a benzene ring. So this is phenylhydrazine. Similar reaction, get phenylhydrazone. Next one is 2,4-dinitrophenylhydrazine, also known as DNP or Brady's reagent. The products are very obvious and what you get is phenylhydrazone. Last one, this is known as semi-carbazides. Here we have NH2 here also and NH2 here also, but only this NH2 will participate in reaction. Why? Because the other NH2, the lone pair, they are in conjugation. So due to this resonance, lone pairs are less available. Hence reaction will take place with the other NH2. And let's write down the products. So before we write down the product, let us write NH2 in a different way. The product is known as semicarbazone. So these 4 plus 7, 11 reactions. First with HCN, second sodium bisulfite, third Grignard, fourth alcohol, and 7 ammonia based compounds. These form the most important nucleophilic reactions. So that was all about nucleophilic addition reaction on carbonyl. So that was all for today's class. See you in the next class. Till then, take care of yourselves. God bless.